Hello, hi everyone. It is day 14 of studying Martin every day, and just another beautiful day. So I'm about to study 2 sessions. So there was some stuff that was going on early in the morning. It is not early the time that I'm studying now. It is 10 a.m. So yeah. So I'm about to do 2 sessions. So yeah, let's start studying. So it is day 14. I'm so glad that I'm on day 14. Like tomorrow will be day 15. So yeah, it is amazing. It is half a month, and today is just like doing 2 weeks consecutively. And this is so fun, to be honest. Like doing, like you're gonna feel a lot of progression. Like you are literally seeing your progress like on your virgin eyes when you do something constantly. So yeah, I think consistency is the key most of the time. Most of the stuff that we learn. Yeah, if you get the consistency, I mean, and then you are literally gonna get good at that thing. Okay, you're gonna be good at that thing no matter what, against all others. No matter if you are damn or even like if you like are low high quality, then still, you can make it. So consistent is all you need. So yeah, so let's start studying. This is the first session, by the way, and yeah, let's do it. Let's continue where we left off yesterday. Okay, so I'm gonna learn inverse variations today. Let me wear my headphones. Let me do my headphones. Let me do my headphones. Okay. Okay. In this lesson, we look at solving equations that express inverse variation relationship, which are relationships of the form. Okay. So in this lesson, we will look at solving equations that express inverse variation relationships, which are relationships of the form of y is equal to k divided by x. So an inverse variation relationship. So let me try to retain some information from the last lesson, from the previous lesson, basically. I'm not gonna open any notice, like, yeah. So it was inverse variation. This one is inverse variation, right? And that was one and the previous lesson was direct variation. So the direct variation was all about just like, if one variable changes, like if a dependent variable changes, the independent variable also changes the same amount. If it increases, it also increases. Okay, and the constant should always be the same. So no matter what, like, how do I put this? How do I? Okay, whatever. So it's all about, if you get 3 different inputs, they will give you 3 different outputs. Okay, but the constant should always be the same, and that's what makes a direct variation. But like this one, today's lesson is all about, like, if one variable, I think, goes up, the other one goes down, or like if one increases, the other one decreases. Okay, or if one rises, the other one falls. That's how it is, I think, basically. And the formula was just like, if you want to get the y, you're gonna multiply x by k, and to get k, you're gonna divide y by x. So that's how it was. I think all I said is valid. Okay, in an inverse variation. Okay, in an inverse variation relationship. Okay, I was missing something. I didn't know that. This is what I was missing. So to demo this one. what I was missing, man. Okay, so an inverse variation relationship, we have two variables, usually x and y, and a constant usually k. Okay, the main idea in inverse variation is that as one variable increases, other variable decreases. Yes, as I said, that means that if x is increasing, y is decreasing, and if x is decreasing, y is increasing. Okay, so that means the dependent variable always goes the opposite. Okay, so the number k is a constant, so it is the same for all the values of numbers x and y. That satisfies the equation. Inverse variation can also be called inverse proportion. Okay, what was like, I think there is something like this that the Chinese teacher was mentioning, Edward, basically. I think something like this, proportionality or something like that. I don't remember. Okay, this is the one.
Just to fill that out.
Okay, constant of proportionality, that's what they call it. And what about this one? Inverse variation, yes, so it's different. Okay, inverse variation can also be called inverse proportion because the variables x and y can be said to be inversely proportional to each other. Can be said to be inversely proportional to each other. I don't know what that means. So variables x and y can be said to be inversely, I don't know even how to pronounce that word, proportional to each other. So we're gonna pull up the Copilot. So we need its help. Why x and y are not? So I have to start all the way from there. I don't know. Okay, is this what you need? Okay, inverse proportion. I don't mean that. What do they mean by? What do they mean by? Inversely proportional. I think it's just like the same. It's just like, I think it's the same as saying if one goes up, the other one goes down. So they are, that means inversely proportional. Okay, so it's just like if you travel a long distance, right, that will increase, right? The amount of distance will increase, and then the amount of gas that you will be using will also go down, because like your gas gonna go down. So it's just same as that, because like they're just like inversely proportional. That's how I got it, but like let me know, what do they mean by inversely proportional? Okay, when two quantities are said to be inversely proportional, it means that they are linked in such a way that one increases, the other decreases, and their product always stays the same. Okay, I think this is the same thing that I mentioned. Okay, if y is inversely proportional to x, then y equals to k divided by x. Okay, wow, this new formula, okay, where k is a constant. This relationship ensures that x times y equals to k no matter what values x and y take. Okay, example, suppose y equals k, which is 12, and x Okay, so x, if x is equal to 2, then y is equal to 6. So if x is equal to 3, then y equals to 4. If x equals to 6, then y equal to 2. Notice that each case x and y is equal to 12. That's the hallmark of inverse proportional. Okay, this relationship is that x times y equals to k no matter what values x and y take. This is something I have to keep in mind, to be honest, so as I go through this lesson. Okay, the main idea in inverse variation is that one variable increases and the other variable decreases. That means that if x is increasing, y is decreasing, and if x is decreasing, y is increasing. The number k is a constant, so it is the same for all the values of numbers x and y that satisfies the equation. Inverse variations can also be called inverse proportion because the variable x and y can be said to be inversely proportional to each other. The constant of proportionality is the number k. So the constant of proportionality is k. Constant of proportionality is k. Okay. Similarly, direct variation can be called direct proportion. In that case, the variables can be said to be directly proportional to each other. Okay, similarly, direct variation can also be called direct proportion. In that case, the variables can be said to be directly proportional to each other. Okay, and inverse variation can be written in any of the following three forms: x y is equal to k. Okay, x times y is equal to k. Okay, y equals k divided by x, and x equals to k divided by y. So let's look at an example. If we know that y varies inversely with x, and x is equal to 10 when y is equal to 4, what is the constant of proportionality? If we express y as a function of x, and if we express y as a function of x, what is that function? So what is the constant of proportionality? Okay, so to get this, when you get the x and y, to get k, you only need to multiply these two, I believe, right? And they will give you k. So you will multiply x and y and they will give you k. Is that how it is? Yes. Okay, and if we express y as a function of x, and if we express y as a function of x, what is that function? Okay. So the formula for an inverse variation is, okay, I got this. Okay, we know that x is equal to 10 and y is equal to 4, so this will be 40. The constant of proportionality is k equals to 40. If we express y as a function of x, we get y equals to k divided by x, and y equals to 40 x, okay, divided by x. So let's look at another example. So I want to go back to this, and if we express y as a function of x, what is that function? So the function will be this. Okay, so the product, okay, example, the product of two numbers is always 100. The product of two numbers is always 100. Describe the relationship between the two numbers as a function. Okay, describe the relationship between the two numbers as a function. Numbers as a function. Okay, let me read it again. The product of two numbers is always a function. The product of two numbers. Okay, so it is x times x. Okay, times y maybe. Okay, it's always 100. So we need to find the two numbers. Describe the relationship between the two numbers as a function. Okay, describe the relationship between the two numbers as a function. So we're gonna say something like this, I believe. I think. Okay, maybe y. Let's use y is equal to two numbers. Let's use n and x. So I wrote it as a function. I think this is how you do it. So the equation xy, the equation x times y equals to k express an inverse relationship. It means express an inverse relationship. It means that for all pairs x and y that satisfies this equation, the product of x and y is always the same, namely k, right? So this relationship ensures that this is the thing. This relationship ensures that x times y equals to k, no matter what values x and y take. So that's why it is already like constant, right? So in this example, x and y equals to 100. So in this example, x and y equals to 100. So k equals to 100. If we express y as a function of x, we get. So if we express y as a function of, okay, so this is not valid then. Okay, describe the relationship between the two numbers as a function. Are these two different? If we express y as a function of x, okay, describe the relationship between, yes, this is probably different, I believe. We get x, we get y is equal to 100, which is k divided by y. So yeah. Okay, sometimes we will be given a pair of equations that involve the same inverse variation equation. Oh, oops, wait. Sometimes we will be given a pair of equations that involve the same inverse variation equation. They have the same constant of proportionality, and we will need to solve for one of the variables. Just as with direct variation, we call this type of problem a two-step problem. So solve the two-step problem given that x and y vary inversely if k divided by 5, which is like the 5 is the x, right? Okay, and this is the y, I believe. Okay, if k divided by 5 equals to 3, and k divided by x is equal to y, find the value of x when y equals to 30. So what you need to do is this, I believe. Go in there. Okay, this is what you need. So if k divided by 5 equals to 3 and y is equal to, and k divided by x is equal to y, find the value of x when y is equal to 30. So they gave us the value of y. Okay, so we have to find the value of y. So before that, we need to get the k, which is the constant. First of all, find the k, and the way we're gonna find is this. So we got k divided by 5 equals to 3. So we need to isolate k. So we're gonna multiply 5 on each side. So these two will cancel. So k is equal to 15. So find x when y is equal to 30. So now we get the k. The k is 15, and we need to find the x when y is equal to 30. So okay, wait up, this is the k, which is 15. Okay, how can I isolate x when it is in the denominator? Okay, find the value of x when y is equal to 30. So to find the y, you need to use what? Let me go and check. Okay, to find y, you need to I'm right, man. I'm right. Okay, so how can I isolate x? Because like I need x, right? Okay, to be honest, I don't know how to isolate a variable, you know, when it is in the denominator. I know like when it is in the numerator, but the denominator, I don't know. So let me check how to isolate a variable in an equation when the variable is in the denominator. Okay, you're gonna multiply both. Is it just like the same? Yes, it's just like the same. Then you're just gonna multiply x, right, on both sides. So these two, they will cancel and you will get 15. Okay, and then 30x. Okay, so you're gonna multiply this side by 30 and this side by 30, so they will cancel. I would like to say this. Okay, so if I divide by 15 and by 15, it will be 1 and 2. So I don't know if this is the right thing. Okay, so this is the value of x. So we will solve the first equation for k. So k is 15. Okay, no, we will take the value we found for k and we will plug that and the value of y is 30, okay, into the second equation to solve for x. So blah blah blah, so x is equal to 1/2. Okay, so decimal equations. So before I jump up into this, I guess I can also listen one of my GOAT's lectures. GOAT's the organic chemistry, the GOAT himself, the best like tutor ever. Okay, inverse variation, algebra 2. Okay, directly joint. Oh, what about that joint thing? I don't have it in my course. I think it is not in my course. Okay, inverse variation. Okay, so I know how to solve more problems, so I'll just click this one.
In this video, we're going to go over direct, inverse, and joint variation divided by 3 is 40. You hear the word. So when x needs to divide both sides by 3. So when y varies directly with x, these two are proportional. So if you were to double the value of x, y would double. If you triple the value of x, which is what we did. So now let's solve. Y varies inversely with x, so the equation that we need is y is equal to k divided by x. After you write the equation, use the first part to solve for k. So y is 48 and x is 4. So how can we solve for k in this situation? Let's cross multiply. 1 times k is k, and 4 times 48, that's 4 times 40 is 160, because 4 times 4 is 16, and 4 times 8 is 32, so this gives us 192. Now that we have the value of k, we can find the value of y when x is 8, so we can answer the second part of the problem. So starting with the equation, let's replace k with 192 and x with 8. So what's 192 divided by 8? Well, we know that 192 is 48 times 4. And 48, let's make some space. 48 is 8 times 6, and we still have the 4 on top. So notice that we can cancel an 8. So 6 times 4 is 24. So therefore, 192 divided by 8 is 24. So when x is 8, y is 24, which is the answer that we predicted earlier. Because it's inverse, we said that as x goes up, y goes down. So if we double the value of x from 4 to 8, y decreases from 48 to 12. So x, it went from 4 to 8, we increased it by a factor of 2. And for y, it decreased by a factor of 2. It went from 48 to 24. Y varies jointly with x and z. If y is 36 when x is 2 and z is 3, what is the value of y when x is 4 and z is 6? So whenever you hear the word jointly, it's direct variation but with two variables. So because this
So number one, we've got a final solution of 55, and very helpfully, we also have some lines of working there. I always love seeing working because it means I can see what you're thinking. And so whether your answer at the end is right or wrong, I can know how you got there and why. What do you guys reckon? Who's in agreement to 55? Yep, got a lot of that. Thank you very much. And what's great is, if that wasn't right, we could actually backtrack through and say, well, maybe if my working disagrees with...
Well. This is not what I was studying, right?
So number one, we've got...
Are there inverse functions? Oh my gosh. That would be tough. Let me solve some more problems maybe. Let me take this. Okay, I didn't take any notes too. Oh my gosh. So let me go back a little bit. So I'm gonna work on these problems. They look very simple, to be honest. But I'm gonna do it. Whatever. Required and rational function. Dude, you know, like yesterday, I was using Skyledger the whole time. That I didn't even like write anything down on my book. No way. That's crazy, to be honest. Okay. But this one is just simple. All we need is to multiply 7 times 3, which is 21. So okay, it's 21. We don't even need a book. We don't even need a book. Okay, so what is the question? If k divided by 4 is equal to 3 and k divided by x is equal to 4, find x. No way. So we first need to find k. Okay. Yeah, we first need to find k. So 4k, 12, 4, okay, 12. Is it 3? Like that as? What about? Wait up. What are they asking me? Isn't it find x? The heck? But I'm not even close though. fine, I guess. So k is equal to 3. By the way, and step D. What am I missing? I know this is what I have. What I have, if k divided by 4 equals to 3 and k divided by x equals to 4. So that's the y, right? Okay, fine, I guess. Okay, let's find k first. Let's find k. This is how we're gonna find k. Divided by 4 is equal to 3. So we're gonna multiply 4 on each side. So this will be k is equal to 12. K is equal to 12. Okay. So yeah, I know what I did wrong. I know it now. So I'm gonna find the x, right? So to find x, then 0 while equal to 4. So I go 12 and I guess equal to this is the one that I'm looking for, and y is just 4. So I'm gonna multiply each side by x. So this will cancel, and then it will be 12 is equal to 4x. So to isolate x, we're gonna divide by 4 on each side, and they will cancel. So x is equal to 3, right? 12 3, yes, it will be 3. So yeah, so let's see. Let's say B. I was right then. It's the mistake that I made. Wow, I like this. Okay, suppose we drive a car to the store, and the time it takes us to get there depends on whether or not we speed. Okay, if our drive times, if our drive times are recorded in the table below. Okay, how long does it take to make the trip at a speed of 30. Okay. Okay. Steve Hardy, big time. At a speed of 30, right? Okay, okay. Okay, okay. Okay. So I have to write this one down on my book or choose a Scarlet Row, but whereas I cannot write all of this, dude, to be honest. Copy image. Just go right here. And I literally, oh wow, I can copy it. Why does it keep saying Barson? I don't know. I don't know what's wrong. It is saying bending forever. Okay, it's not working. Is this the same? Maybe I need to refresh the page. And then just like... I don't know. I don't think there is the network. Network's fine, maybe. I forgot it, man. So I can literally do this. So to get K first. So to get K, this is what I need to do. To get K, I can just multiply, I guess, times Y. So one of these cases, I'm gonna use the speed should be the X, to be honest, and the time should be the Y. So I'm gonna use 60 and 10. So 60, which is, and 10. So this will be, I think, 601. Okay. So K is 601 at this point. What the? Okay. Okay. So if, what about if, how, like, I want to get the time. Okay. So it will be Y equals to K divided by, I guess which is the speed. So I can say K, which is 601, divided by, I guess, which is 30. So I don't know this. Okay. Let's calculate maybe. This 101 divided by 30, 20. So this is 20. Okay. So let's check. Let's see. This the B. Swear to God, I'm just gonna say it. I don't know if you will be right. Oh my gosh. I wasn't expecting it, to be honest. I wasn't expecting it. I was just like doing it, but like I wasn't expecting it. I wasn't sure, like. Yeah. So yeah, I got 10 minutes of break and yeah, let's chill. Oh my gosh, dude, I'm literally forgetting to set up this post section 2. Let's make it section 2 now. Oh, I'm feeling sleepy today, and that's why I'm reading stuff out loud. Okay, that's why I'm reading stuff out loud. So I'm feeling sleepy. Last night I couldn't sleep, dude. I got an insomnia, I believe. So I was trying to go to sleep a whole fucking hour, and I was just like, I turned off my phone. It was still like I put it somewhere that's away from me, and I was trying to catch some Z's, but like I couldn't. I was lying down on my bed a full hour, and I couldn't catch some Z's, and I couldn't like feel sleepy. And after that, I just like grabbed my phone and I started using my phone, and I slept probably somewhere late. I slept like 2 a.m. dude. That's crazy. Yeah, it has to be changed, but it's not something that's depends on me. Maybe I'm missing some vitamins, I think, and that's why I'm getting the insomnia. I was not on coffee too, right? But yeah, here's what it is. When I go grab like maybe a cup of tea, I don't know, maybe something to eat. So let's start our second session. And I'm gonna move on to, I don't wanna solve any other problems. You can just like move on. So I needed all of them. So I'm gonna go with this lesson, decimal equations. What else? This one. Okay. Upgrade. So let's start. In this lesson, we will learn to solve equations with decimals by multiplying by powers of 10. Remember from pre-algebra that we can identify the place value of any digit. Okay, so yeah, 10 is place and 100 is place something. Okay, 0.1 has a 1 in the 10th place. Okay, so 2 has 2. 0.02 has a 2 in the 100 place. Okay, and 0.003 has a 3 in the thousands place. 0.004 has a 4 in the 10,000s place. When we multiply by 10, move the decimal point 1 point to the right. Okay. Notice that we move the decimal point to the right 1 place for each 0 in the multiple of 10. One method of solving an equation with decimals is to multiply both sides of the equation by 2 by a power of 10 in order to solve an equation involving decimals. The first thing we will do is get rid of the decimals by changing them to whole numbers. Let's do a couple of examples. Solve the decimal equation. So you're gonna move, this is in the 10th place, right? So we're gonna move the decimal 1 point to the right. So we're gonna say 1 point. So that means it will be 3.0, but yeah, you're gonna forget it. So you're gonna say just 3. In order to solve this equation, the first thing we will do is to get rid of the decimal by changing it to a whole number. Since the decimal in our equation ends in the 10th place, we will need to multiply both sides of the equation by 10 in order to change the decimal to a whole number. So you need to multiply both sides by 10. Wow, I wasn't expecting it, to be honest. Okay, so let's do another one. So you're gonna multiply, so you're gonna be like, this is just still, there is a 1 in the 10th place. You're just gonna multiply by 10. So you're gonna multiply positive 10. You won't like care about if it is minus. So yeah, it is positive 10. Yeah, man. It's equal to 0.01. So they change it to centidecimal. Okay, let's look at another example. Solve for the variable 0.4n plus 39 5.78. So you still okay. This one got a 2 digits, right? And this one just go only one. Okay, let me just a little bit go back and clear this. So yeah. So I don't know how they're gonna deal with this. Like this side of the equation, they got a decimal, right? And also they got a decimal. This one is just like the 4 is in the 10th place, but like this 2 digits are in the 100th place. So I don't know how we're gonna approach this. So in order to solve this equation, the first thing we will do is to get rid of the decimal by changing them to a whole number. Since it's the longest decimal in our equation, it is in the 100th place, we will need to multiply both sides by the equation by 100 in order to change all the decimals to a whole number. This means we will move each decimal point 2 places to the right. So this one will be 42. I mean this will be 40 also, okay? Not 42. It sounds like 2. I don't know how to pronounce it, but yeah, it is what it is. Okay. In order to solve this equation, the first thing, okay, I got it. So you're gonna multiply by 10, by 100, I mean. So it is what it is. So you're just gonna look for the like this. Since it's the longest decimal in the equation and is in the 100th place, we will need to multiply both by 100th place. This is all you need. This will make sense. Okay, yeah, it's important. We will need to multiply both sides by the equation, both sides of the equation by 100 in order to change all the decimals to a whole to whole numbers. This means we will move each decimal point 2 places to the right. Okay, and the rest is just the same. That's why I'm scrolling down. That's why I'm scrolling down, because like the rest is just like a normal way of solving an equation. Okay. Wow, I locked another tool that I can use in the future. I learned another tool. You know, like all of this technique is just like some type of a tool that you are learning now, and then you're gonna use it for a problem in the future, right? So amazing. Okay, so solve for the variable. Okay, fraction equation. So before I go into that, I have to take a couple of notes. Okay, I'm gonna take a couple of notes. So yeah, and I think my pen is kind of dead. This is my equation. right. The heck? So, I don't know what am I doing wrong. I don't know what I'm doing wrong. I don't know what I'm doing wrong. So in this case, I go 0.04, I guess, minus 0.2 equals to 0.1. So we're gonna multiply 100 by each side because like 4 is in the 100 place. So we're gonna say 100 divided by 0.04x minus 0.2 is equal to 100 times 0.1. So this will be 40, I guess. Okay, so we're gonna take 2 digits to the right. Minus. So this will be 20 also. It's equal to 10. So plus 20 on both sides. Plus 20 on both sides. Then 40, I guess. It's equal to 30. So divided by 40 on both sides. So I think they can simplify further, and that's what I'm doing wrong, I believe. So divide this by 3, it will be 10. What about this one? Is that possible? Can I divide 40 by 3? I don't know, to be honest. By 3? Nope, so I can do it by 2. So this will just be 15 divided by 20. So 15 divided by 20 divided by 20, it will be 0.5. It will be just the same. So there is something that I'm doing wrong, because like the C is not the correct answer. So I don't know what I'm doing wrong. I don't know what I'm doing wrong, to be honest. I don't know. Okay, do I need to simplify this further, Ifan? Okay, 15 by 3, 20 by 3, nope. This one by 2. To be honest, nope. This one by 5. Yes, 3. Right up. This one by 3. And this one by 4. I think. Yeah. Okay, so what about 3 and 4 then? Will it give me the same? Will it give me the same? Yes, this will give me the same. I don't know what I'm doing wrong. I don't know it. Do I need also to change this into nope, I don't need it. It's a little bit annoying and I don't know what I'm doing wrong. Maybe I have to chill and then make it sure again. Wait up. 100 times 0.04 will be, it will be just 4. So wait up. So I got 0.04. Okay, move 2 digits to the right. Okay, 1, 2, This will be here, and then it will be 4.0000. Forget all about this, so it is just 0. So, okay. It's not a hedge one, it's just 4. It's what it is. So, yes. So let's do it again maybe. So this is 0.04x minus 0.2 to 0.1. So this one multiplied by 100, 0.04 x minus 0.2, 100 again multiplied by 0.1. It will be 4 x plus 0.04 multiplied by 100 means like move the decimal point 2 places to the right, so it is 1 and 2. It will be right here, so that's why it became 4x. Okay, I was missing that, to be honest. And this one, it will be 20 because like 0.2 2 places to the right, 1 and 2. So we're gonna fill another 0 right here, and the point will go there. So this one is just the same too. So it is 10. So this will be 30 for x divided by 4 divided by 4. So x equals to 30 divided by 4, 7.5. So I'm gonna go with 30 then. So yeah, that's what I was doing wrong. Let's just say continue. That was a little bit stressful, although I was doing a clear error. So yeah. Fractional equations. No, not the equations. Let me go with this. Fractional equations. Decimal equations. Up. Okay, fractional equations. Maybe this will be tomorrow's lesson. How many lessons left? Fractional equations, partial equations, radical equations, multivariable equations. So that means it's 1, 2, 3, 4. So I can make 2 tomorrow, and I can make the other 2 like the day after tomorrow. Yeah. Okay. I wasn't expecting it's 50 minutes. I was expecting it's less than that. The section is 50 minutes long. Wow. Alana. This my younger brother is bothering me for somehow, but yeah, it's just a kid. Oh, systems of equations. So yeah, I can just call it a day, I believe. So it was day 14 of studying math in every day. It was a beautiful day, and I learned 2 lessons in inverse variations and also decimal equations. So yeah, so see ya. I will be in it here.